Hello everyone and welcome back to the React course. In this lecture, as I promised earlier, we are going to talk about the most important thing and one of the hardest things related to React. But this is a really powerful concept and this will empower you to do so much more. Now, without wasting any time, let's dive into component life cycles. Now, what component lifecycle really means? Now, component lifecycle really means that, in a sense, what we are doing is we are seeing how components are actually rendered by React, and we are gonna dive deep into that idiom of what is happening and how that is happening. So, what happens is a component are two types. So there are two type of components, right? So there are class-based components and then there are functional components. So today, whatever we are going to talk about only applies to class-based components. So components that extend the component class from React, this discussion is only going to apply to that thing. Also, functional components don't have lifecycle methods attached to them, so they are out of the today's discussion. Moving forward, let's talk about components and class-based components, and let's discuss what lifecycle is. So currently I've opened up our project, or I haven't actually, and I'll go to my browser and I'll go to localhost colon 3000, and this is where our project lives. And today most of our work is gonna happen somewhere around here. This is our console right now and this is our app. Now if I hit refresh, I see a lot of things happening in the console. So this and this and this are the three things that we are concerned with. So what is happening? So what is happening is that here in our app, we are using this app and we are exporting this into our constructor, and index.js calls this. Now I'm going to remove this prop because I won't need this for today's lecture. Okay, so once I've removed that, let's come back to app.js. So what happens is when React sees this app component, the first method that is called when it decides that it's gonna render it to the screen is called constructor. Now, as I already told you that in React, every single method receives props. So that's why constructor gets props, because it's the first method that is going to be called. Now why there is super? Because what happens is when we have this app class extend the component class, all the lifecycle methods that I'm going to talk to you about in a little while are implemented beforehand in components. So that's why you need to pass props to that, because constructor and other lifecycle methods of component needs to be called over props. So that's why we use super. Now ahead of this is just some implementation detail that I'm going to talk to you about later, but you can see clearly that I have a console.log now here, and I'm just going to remove that and I'm going to take it upwards. I'm going to remove this and let's look at this. So what happens when our app loads is, you can see here clearly that I saved it again and it reloaded. So the first thing that is being called is the constructor, and here is the proof of it. Then what happens is when our constructor is done calling, then the other method that gets called is render. So there is also a console.log in render. It says render is called, and that's what happens when, so the second step is render gets called. So here is render is called. Now these two steps we have done before, and these are familiar to us because we have done those before and we've seen these before. Okay, so what will happen after this is third method that is called, so currently what is happening is these are called methods that are called on mounting. So mounting and unmounting are the process of starting and ending. And there are three major parts or three major positions a React component can be in. So one is mounting, the other one is updating, and the last one is unmounting or removal. So what mounting is, whenever a component is on our screen, so right now we have our component on our screen, this is our component, so it's already mounted. Okay, and now there are two possible things that can happen. It can either update or it can either remove or go out. So if I close this page, this will unmount, and if I increase the number or do something else, then it will go in a state of updation. Now mounting is done when the browser loads this component, or say logically from the prior times, you remember that we had three different components called home or about and contacts, and with some logic we are switching between components. That's when mounting happens. So what are the three things? Mount, update, and unmount. Now going back, the methods, that the cycle that happens while mounting is, first of all, the constructor gets called. Second, what happens is the render method is called. So the render method is called, the JSX is evaluated, and everything happens. Now the third method that is called while in the process of mounting is called component did mount. Now this is something new, so I want to take my time and explain this properly. Component did mount. If we try to make sense of the words that are making this method's name, one thing that this is very specific, this is something that we didn't create, this is something that React requires us to write. So the name is specific, so it's called component did mount, and what it tells you is that React has completed the rendering process. So basically, in simpler words, what this means is that if you want to do anything that is related to using the DOM nodes, then you can do it here. Now what this also marks as that currently React is not performing any action of the web page. So currently React is not doing anything on your web page, it's already rendered the document, and now you can do things. If you want to play with the document, then you can do that here. Another thing that is here is that you might at times want to know when the render finishes, so this method also marks that. So you see down here it says component did mount, and that's what happens right now. It's in a state where it can either go to updating or it can go to unmounting. So on that point it's sitting there, and the last method that was called was component did mount. Now I'm going to come back to component did mount, and we are going to see what use cases are there. So before that, let's jump and let's force our app into updating state. So if I press increase, if you remember from last exercises, it's going to increase this count. If I press increase, now there is something new happening. These three things were there previously. What suddenly happened is render was called again, and there is this new thing that was called that component did update. Now let's look at these two. So what happens is when my component goes into the state of updation, then also a chain of methods is triggered. So what will happen is, first of all, my state is gonna get updated. So calling increase sets my state using set state. Once the state is set and the state has changed, then what happens is we re-render. So the render method is called again, and once the state is updated to a new state, then render method is called again. So we see that render method indeed was called again, and this time a new method similar to component did mount is called component did update. Now what is the purpose of this method is that this method tells React whether the state has changed in a way that we need to update, or basically what this method means is that at its core what component did mount was doing, that it was telling us then when this process is gonna finish, or the process of rendering is gonna finish. Component did mount tells us that rendering has finished at the time of mounting. Component did update does the same thing but at the time of updation. So if I press the button again, then what happens is render is called, and when rendering is done, so basically my new state has taken place and everything is updated on the DOM, then component did update with signal or trigger or give me a signal that okay, I have actually gone ahead and updated your state or updated your layout or updated the whole DOM, if you want to say it like that. Now there is another method that I haven't written till here right now, is this one, should component update. And now I'm going to write a console.log here, and let's see where this sits in. So console.log should component update. Now let's just not go directly to our browser, and I am gonna hit refresh once, and the app is gonna reload there and the count is gonna come back to 0. But let's just think of it right here. There are two things happening here. One, I'm returning true in this method that I am not doing in any other methods. Secondly, this has a name, and that name points to a question, should component update. Now what should component update does is it has a decision to take. What it can do is it can either allow render to happen when this update state happens, or it can say that okay, nothing specific or nothing worthy enough of updating or re-rendering happened, so do one thing, just not update yourself. And I'm going to tell you how this is crucial and how it's going to affect the performance of our app. So let's just go back to our app and see what happens if I click increment this time. So if I click increase, then before render is called, I clearly see that the method should component update is called. Now, as I already told you, that should component update controls whether both of these are going to be called or not, because it controls that whether on changing state from one state to the other, did something significant happen that we intend to change us, that we feel that should re-render the UI. Now let's look at an example. Currently what is happening is if I increase this always increases to a higher number, and that makes sense to call 3 of these. So these 3 all should be called, and it makes sense because if I'm increasing this number, I'm always increasing this by 1, and increasing this should also give me a visual feedback. But say if rather than increasing this number, I'll just set it to 1 every single time. So I'll make this change, and if I'll save this, and if I go here and I'm just going to clear this, and for the first time I hit increase, I see all 3 of them being called. Now no matter how many more times I click increase, the number is always going to be 1. But what you're going to see is that every time I click this, render, should component update, and component did update, all 3 are called. And here the expensive operation is this render. So this is the most time consuming. So we want to save this. So we don't want it to be happening when there is no significant state change, and we want to block all such changes. So if I hit increase lots and lots of times, you can clearly see that I'm just wasting my resources right here. So what I can do, let's go back to our method called should component update. Now here I have access to something called next props and next state. So what next props and next state are is that currently I have a state, and next state points to what the state is gonna be once these changes that you intend to apply are applied. And next prop is also similar. So how the props are gonna change when the changes you intend to apply are done applying. and currently I have access to something called state and props. So I want to control the rendering, that if the state is not changing. So what I want to do is, if this dot state dot count is equal to this dot, now I want to see if new state or next state has the same value of the count. So because in this case I don't want the render to be called, because nothing significant changed, so I'm going to return false. In this case what is happening is the value is 1 and I'm also updating it to 1 every single time. So if that is the condition, then I don't want it to change, because in that state I don't have an effect on my UI, and rendering and or specifically re-rendering is not having any significant effects, and I'm just wasting my performance, so I shouldn't do that. So taking such decisions is possible because of should component update. And should component update gets two parameters, next prop and next state. The first parameter is next props and the second one is next state. Now you can take a decision based on any logic you want to, not just state logic, or if you have some different logic in your app, you can do whatever you want to. Just if you return false, render will never be called, but if you call true, then only render will be called. Now as we see we have made this change, let's go back and see what happens. So I'm back to my app, and if I clear my console right here, what I do is if I increase this count by once, it will become, and I get this error. Okay, done something and I didn't comment that, so I'm going to comment it now, and we are going to look at that later. So for now I'm going to increase this, and I get an error that this dot next state is not defined. Oh sorry, I don't actually need to use this, I just need to use next state because it's passed to me as a parameter. I'm really sorry for that one. Let's go back and let's hit increase, and now we clearly see that. So I'm going to refresh my app again, and this time I'm going to clear this prior. Now what we will do is we will increase this once, and we see all three of those are called. So, and that's actually also the intentional behavior we want. If the count is increasing to something that we want it to increase, so from 0 to 1, we want to show that on the UI, and that's why render is called. That is fine. Now if I click this again, and you can clearly see that I'm going to clear this again. Now if I increase this again, only should component update is called, because changing my state this time made my state 1 again, and previously it was 1, now it's also 1. So in that case I don't want to actually have that render, and if I don't get that render call, the should component did update call won't actually happen, because that's dependent on the execution of render. So that's how I can make my app lots faster based on just saving some time. Updating state in a manner that is not affecting my UI will not be triggered here, because I am actually capturing that condition right here, that okay, if this is something that is happening, don't do anything. Okay, now if this sounds good to you, let's do another example. Now let's go back to component did mount and see what kind of things we can do in component did mount. So if you come back with me a little up top, we have this variable called interval, and it's set to undefined. Basically undefining meaning that there is no specific value to it right now. And then in state I have something called time, and it's actually null. So let's try to make a clock display on our website or the web we have right now. So to do that, you might know that there is a thing called set interval, and what set interval does is it takes two arguments. So what are those two arguments? The first argument is a function, so I'm going to give it a function, and the other argument is a time value, say 1000 milliseconds, and this number is in milliseconds. So whatever this function is going to be, it's going to be called every 1 second or 1000 milliseconds. Now what I want to do inside here is I want to set the state. So this dot set state, and what I want to do is I want to change the time to new state dot to local time string, and I'm just going to call that method. Now what's happening here is I'm calling this dot set state that is used to update state, and I'm updating the key called time. And what this means is that it's just a fancy way of saying what is the current time, and this gives me that, and to local time string means convert it into a method that is suitable for displaying on the screen. So if I save this right now and I go back to my render, you will see that I already have a time displaying logic. So if this dot state dot time is false or null, because null counts as false, then I was returning nothing. So previously that's why you weren't seeing anything. But if it's not null, then show me whatever the value of variable has. Now if I go back and if I refresh our app, you will see for a second there is nothing, and it never shows anything because I have done something. Should component update is called over and over again, but it's not rendering our app. Okay, let's just return true every single time, and let's go back to our logic. So here we are, and if I save this again, if I refresh this, if you see right now, if I refresh this, for a fraction of a second you don't see this time happening, and you don't see that time happening because at that particular point it's the first render, and during the first render what I'm asking it to display is nothing. So to fix that thing, what I can just simply do is new date dot to local time string, and what this will do is this will fix that problem of ours. So if I go ahead and refresh, now you see the time is always there, and I can actually increment the count going ahead, and it's always gonna be 1 because I've changed the logic. And if I go back and change this logic again, so state dot count, sorry, dot count plus 1, then I can clearly see that now I can do both things. So I have time, it's actually being updated over and over again as intended, because this method, this thing right here, this whole bit is called every 1 second, and every second I'm changing the time to the current time. So it's basically similar to counting my time over and over again, but rather than adding to it myself, I'm just using the inbuilt classes to get the time all over again. So that is what is happening here. Now if say I have also changed that, so if I go back and refresh this now, what I can do is I can increase the count, and my clock never stops because it's actually interacting with that set interval thing, and set interval calls it every single second. So it doesn't matter if I increase or decrease or change the state automatically or manually, it doesn't affect by that, because set interval is by default calling that set state method every single second. So if I increase it further, doesn't affect the performance of this clock, and it runs smoothly. And these are the hours, minutes and seconds. So we have successfully created a clock. Now one thing that is also a performance decay or a performance lowback is that set interval methods, or methods like set interval that are called over a period of time regularly, need to be stopped sometime, or else what they'll do is they will keep running in the background even if your web page or the component that is responsible for that set interval is constantly called. So what will happen is we need a way to stop this set interval somehow, and that is done by pointing to this. So what I'm going to do is I'm going to take this and I'm going to store the. So what I'm just doing is I'm getting a reference to the set interval in this dot interval, and this is the field that I defined above. Now this is a really great time to showcase this method called component unmount or component will unmount. Now this method is called when the component is sure to unmount or a action has been taken that will unmount the component from our given screen. And what that means basically on a broader scale is that whenever this component stops from execution or this component goes out of scope to say, or in layman terms, this thing right here is not showing on my screen anymore, then in that case this method will be called. Now this is also called housekeeping method because this method is used to clean all the processes that are happening on regular intervals. So say if you have a clock on your website, or if you have some data coming over the network over a regular period of time, say 5 seconds, 10 seconds, or whatever, then all these things are happening over a period of time and those are being executed by JavaScript. So you have to tell JavaScript, okay, now this component is not using those anymore, so you need to clean those. If you don't do that till your website is in scope, and no matter what components are being mounted, this will continue to be running. So this is a good practice in JavaScript. Now there is one good thing that saves you a lot of pain with shoved component update, because you in a bigger app you might have lots and lots of values inside state, and you don't always want to do that should component update by yourself. So there is a thing that comes with React called pure components. And now what is the biggest only difference between components and pure components? That pure components have this method should component update already implemented inside them, so you don't have to implement this method yourself. And what that does is that will only call render when it sees a significant state change. So if something genuinely changed inside the state, then only that method will be called, else that method won't be called. And what that method means is I'm talking about the render. So if I'm doing an action that will change the state in a significant manner, then render will be called, else render won't be called. So if you don't want to implement should component update yourself, then what you can do is I'll write in a comment, instead of using component, use pure pure component, and that's it. Then you don't need to implement this method. And one more thing, if you're using pure component, then you shouldn't actually implement this method, because if you implement this method on your own as well, then it will override the method implemented by pure components, and then whatever your implementation is going to be used. So if you want to write your own should component update method, then you should use components. And if you don't want to write and still get the functionality and the efficiency of like writing it on your own, then what you should do is you should go ahead and use pure components. Okay, now with that being in mind, let's do a mini exercise in which we are actually going to create another component. So I'm going to create a functional component here, and I'm just going to call it t or something. So say t, and what t does is t has nothing but just a return. So just this, and inside here we have a div, and inside this div we have a closing div, and it says other component. And now what I want to do is I want to create another class based component that will switch between app and T, so that we can see our component will unmount in action. So what I'm going to do is I'm going to write class control extends component, and in here I just want to do something like render return, and basically either I'm going to just use app or I'm going to use T. And how I'm going to decide whether I'm using app or T is I'm going to have a state variable. So state, and here what I'm going to do is I'm going to write using T, and I'm going to set it to true. Now what I'm going to do is I'm going to up top create a button, and this one is always going to be on the screen. So button, and on click of this button, and I can't, so on clicking this button what should happen is we have an arrow function, and we are going to call this dot set state, and we are going to change using T to, actually we're going to set it to true, and initially it's going to be false. So here false, and I'm just going to give it a name. So let's call it change, and then the button gets closed. So this button is now closed. Now what I want to do is I want to have a condition. So this dot state dot using T, if it's actually true then I want to give out T, and if it's not true then I want to use this app. So once that is done I'm going to write it like this, and for above this I need a div to have both of these inside that. So this is here, and I'm gonna cut it, sorry for that. Let's just cut this and paste it down bottom, right? So everything seems fine. Now instead of using app here I'm gonna use control. So control is gonna be the component I export, and if I go back to my browser I should see a button up here, and it's called change. And currently I am gonna silent all the console.logs but just one. So let's just comment this, and by silenting I just mean commenting, and comment this, and also comment this, comment this, comment this, and write a console.log here, component and mounted successfully. Okay, now I am actually not going to implement this method right now, and I'm going to comment it for a second, and I'm going to go up, and before updating my state I'm going to do something like console.log clock called. Okay, so what clock called basically means is that I am still using my clock. So if I go back to my browser, and if I just go here and I refresh, then what it tells me, okay, I just didn't comment the render bit, so I'm just going to actually remove this because I don't need it further. If I go here now, the only thing I see being called is clock called, because the only thing that is updating on the screen is this clock is being called. Now what I want to do is I want to press this button and see if I press this button what will happen is my component changed, but this is also updating still. And see how smart React is, it actually gave me a warning signifying that On my previous component, I started a set interval, but I never finished it while I was exiting the component. So it tells me exactly that, and the fix should be using component will unmount method. So let's do exactly that. And in this case, what I'm going to do is I'm going to uncomment my component did will unmount, and I'm going to save this, and I'm going to go back to my browser. And if I just clear this right now, and now we can clearly see that our clock called, or basically our asynchronous set interval method, is still being called over and over again. Now if I get out of this component and I press this button, see how it's not being called anymore. I don't get a warning from React that this might cause performance issues, and my component unmounted method performed it successfully. So that's what component will unmount does. Now let me talk to you about applications of how each one of them can be used. Let's talk about component. Let's talk about the constructor. So in the constructor, what you can do is you can set the state, and you can also bind methods from this. So what we do is we set interval, we set state, and we also bind methods. So this is called method binding. This is state. We can also make other class fields, and so on and so forth. Now component did mount. Component did mount, as I already talked about, is used to do something with the DOM, because this method signifies that okay, now you finally have a DOM ready and now you can interact with the DOM. So that's why for mounting a set interval on the state, we wait for it. Now in this method you can actually use set state to change the state, okay, but in the other methods you might not be allowed to. So here you can use set state. Now I've already talked about should component update. Component did update is very similar, and we have also talked deeply about component will unmount. A practical example would be if you have used something like Google Keep, then in that what you do is if you start writing a note and if you just go back, there is no save button. So if you know, there is a modern feature of autosave. If you are on a form, if you are filling the form and you just go back, then they never ask you to save it or anything. They automatically save whatever your state is currently with the app, and that is done via using something called component will unmount. So they listen to when your component is unmounting or when you stopped interacting with that component, and whatever state you were in before stop interacting with your components, they save it, so that when you come back to them you can start from where you left. And that is a really important user feedback or great feature if in your app. So if you have implemented something like that, your users will love you for that. So on that note, you have learned all the basics that were required to build React apps, and from the next lecture we are going to start building our project. Thank you so much for watching, and I hope I helped you. See you later. Bye bye.